Right, so our next speaker today is, I wish I had something witty to talk about all our speakers, but yeah, I'm lazy, and so.
It's okay.
Matthias comes to us from Travis CI in Berlin. I've been a big fan of his talks, and actually he's probably the only person I've ever met who's more nervous about giving his talks than I am. So, especially if you've seen his Twitter feed the last couple of weeks.
I'm sorry about that.
So is it? Test to see if
It's not the PDF. Oh, you want the PDF? I'm sorry. Okay, good. All the fonts, so we're going to want to change that to Meyer.
Because you want to see your slides, I presume, or are you going to walk?
No, it's okay.
Okay. So display
That takes too long, but it's good.
arrangement, Meyer. Done. Shift F. And you're probably going to get the little arrow thing at the bottom, but just ignore it.
The little arrow thing?
Like when you click it, it pops up the little
Okay,
toolbar. You should be
cool.
okay.
All right. Well, hello. My name is Matthias Meyer. As Jason said, I come from Berlin, Germany. And I'm very thankful to be here. And I'm here more as a user of monitoring solutions than building them myself. But obviously, I've built my own collectors and alerting solutions just to avoid the inevitable of using that unnamed alerting and scheduling system. But I do most of these things to help keep running this little continuous integration platform called Travis CI, which is my day job, if you will, running the infrastructure for that. And we're a very small team. We're 5 engineers at the moment, and I basically do everything I can to make it easier to make sure this doesn't happen. Actually, that was the wrong slide. I make sure this doesn't happen. This is our motto. As we're a very small team, we're just we're engineers coming from very different backgrounds, and we fail a lot. We have a lot of, and obviously, I know that a lot of you have similar problems as we do. So we just try to not make a big deal out of it. It's just what happens a lot. We had several outages last year, and every outage gave me something to think about to improve our monitoring and to make it better, and to think about the human side of things. John already set the stage for that, and try to go into a similar but also different direction than that, because I look at it from a much smaller perspective. From how can I ensure that my small team of engineers, who also have to run this whole platform, can run this platform efficiently, and can if I send them an alert, which I'm still doing a terrible job at, making sure the alerts are designed properly. If I send them an alert, how can I make sure that they can deal with that alert in a way that allows them to deal with it efficiently? To know where to look for data to, confirm the suspicion of what the problem is, or where to look in the log files, and all of that to prevent this from happening. We've had several occasions where this actually happened, but we just get up and continue to do so. Continue doing our thing. Thanks to a certain thought leader in the room, I enjoy looking into other industries as well, a lot. But I want to look into a very different industry, one that keeps me busy during the day, that I spend a lot of time thinking about, and that is coffee. I spend a lot of time drinking coffee. I spend a lot of time contemplating coffee, the art of making coffee. But it's a fascinating thing, and I spend time in coffee shops as well, and in particular in coffee shops that have coffee roasters. There was one coffee shop in Berlin where I just walked up to the guy and saying, "Oh man, what do you have there? Do you have graphs? Awesome, I like graphs too." And he was just standing at his roasting machine, and you saw the graph go up. Basically, when you roast a coffee bean, you add a lot of heat in the beginning, then it eases out a little bit. It cools, the beans cool down, and then you add another pile of heat to get to the first crack, which basically is where all the good coffee roasters aim for that first crack, because that means they have a very light bean, which can bring out the best of the coffee bean. But that's an entirely different talk. So you had this graph, and it was very Windows 95 looking. It had wonderful big buttons with gradients on them. It had a black background. And I noticed that it updated itself just every 2 to 3 seconds. And I was like, man, that's awesome that your graph is updating every 2 to 3 seconds. And he was like, yeah, I'd really love it if it would update every, just every second. Because 2 seconds in the coffee roaster can already mean that the temperature has risen or dropped one degree Celsius. I'm not familiar how much that is in Fahrenheit, but it can drop a significant degree. And that can mean, if you miss one step of that, can already mean bad consequences for the coffee bean. And they're just like, they're very, very focused on getting that, on getting that right, on watching every single tick that the temperature changes over time. And then I went to a second coffee roaster in Berlin. He was like, he had also graphs. They were not on a black background, fortunately, and I noticed that his graph is updating like every second. And I was like, oh man, that's awesome. The other roaster, he told me he would love to have a graph that updates every second. And he was like, yeah, it's pretty awesome. And then I noticed one thing. Next to his computer, which is, both had computers attached to their roasters to give them all the information from the sensors in the machine. Next to the computer, he had a sheet of paper. And that sheet of paper, he wrote down every minute the current temperature in the roasting machine, which was fascinating. I asked him, why are you writing that down? You have like this software that tells you, how this graph is evolving, and it has a much finer granularity than what you're writing down on that paper. And he was like, yeah, it's great, but I don't trust it enough. If it loses my data, I won't have a reference point. So for the next roast, you want to make sure the graphs look very similar and that the temperature evolves in in very similar ways. And not only that, he had on his desk he had several trays with beans in different stages of roasting. So he could look at the color to compare. He had a known good data set basically, where he could look at the color and compare it to the beans he's currently roasting to see if the bean is following a similar pattern, knowing that if it follows this color pattern, it's going to turn out to be a great bean. And it was fascinating to watch because it's like the coffee roaster's very own confirmation bias. He was looking at historical data to deduct, what is going to happen at the current roasting stage, and he's going to use that reference for every future instance. And that's like, have you ever looked at a graph and thought, oh man, I've seen this graph spike before. This is what must have happened because it has happened before. I was like, man, that's insane. And that's like, it's not even aviation or anything. It's the coffee roaster. It was fascinating. And both of these are good friends of mine. And I was like, I was just really starting to think about that, just like preparing for this talk. And my mind was blown. How similar that is to how we look at graphs, how we currently make decisions still in the operations, trying to figure out what is happening when a graph spirals out of control. It was pretty amazing. But that brings me back to talking about me a little bit. This is me in 2007 when it comes to monitoring. I was just starting to start out with Munin, and then I had Monet send me useless emails notifying me that some process changed from one state to another, which I'm sure a lot of you have had before as well. It was not very pleasant. But then in 2011, something happened, and I'm sorry, I have a typo in there. Something interesting happened. A gentleman that's in this room started, bringing up the moniker of monitoring sucks. Raising the awareness that the monitoring tools we currently use, that they're far from perfect to help us, make good decisions in production or when an outage is happening. And thankfully, that pretty quickly turned into monitoring love in 2012. And it was awesome for me as a user, as someone who benefits, from every work that is going on in this field, to see what has happened in that time. And my mind was blown a lot, in particular by this one. And we've seen the occurrence of the horizon graph before. It was just a mind-blowing visualization for me. It took me a while to understand what it is. But we've basically seen a lot of improvements when it comes to visualization, albeit still not being not being perfect yet. We've got incredible new insight into what our applications are doing on the network, And we've seen stream analysis for looking at time series data, looking at windows of time series data to figure out, if there's any deviation from standard behavior in applications. And it's been awesome. It's been awesome to see that. But yet, I have one question. How many of you are still using Nagios? I'm not here to dish out on Nagios. It's Jason's job, basically. But Nagios is a lot of things. It is very efficient. It has good alert scheduling and all that, but it's not built for humans, is what I would put forward. It is not very pleasant to use, but most importantly, it's not built for humans. And I want to talk a little bit about what I mean by that, not specifically to Nagios, but how monitoring is still a very hard to approach field to people starting out with it. Because it's what happens in 2013 in monitoring. We may be seeing better visualizations. We may see even more technology problems being solved, but yet the fundamental question that people ask me when I talk to them about monitoring is this: what the hell do I even measure? What the hell do I look at in my application? What kind of data do I track? What kind of data do I need to track on my servers? And as much as I love what is going on there, that's just, every time I talk to people, that's a fundamental question these things boil down to. Everyone who's new to monitoring, it's just like, man, what am I even measuring? And in 2013, monitoring still looks a lot like this. It's a very wonderfully spiky graphs, but the general idea is we still stare at graphs a lot. We stare at time series graphs a lot. We look for common patterns to see whatever has happened in the past confirmed. We look at spikes like that really, really big one, which is bad news for us, to try and figure out, what the hell has happened in our infrastructure. We put a lot of graphs on top of each other to try to figure out the patterns and to try to figure out what happened. But the fundamental question is still, what the hell do people even measure? And that's, from my experience, talking to a lot of teams and even smaller companies who, just want to focus on their own product, is still an oddly unsolved question. And I would love to see more focus on helping people understand what it means to measure in their application, what it means, to focus on what stuff they need to focus on in their own code. And it took us a long time to get it to focus, to pinpoint on a location that would make sense for Travis CI, for example. Like 14 months ago, Travis CI didn't have any monitoring. That was not great, because we basically had the community of the open source community always tell us when the site went down, and it went down for half a day, and it was not great because we've been growing insanely since that time, and we're still growing, and it was just in general, it's not pleasant when your users tell you that your site is down. So I spent a lot of time adding monitoring to all parts, but then it took me ages to figure out what is the defining metric of Travis CI. The sole metric, as I dubbed it. And it turns out it was something like this. I looked at the only real thing that is happening in Travis CI is a GitHub request comes in, we schedule a build, and we start the build eventually. So we started looking at the time of when the last build was started and when the last build was finished. You'll see like this crazy spiky graph, because it goes up to, there are times when you have 2-3 minutes that go by without a build being scheduled, or a build being started, or a build being finished, and that's okay. That is, it probably will never reach that threshold that we have set to figure out if there's a problem on the platform. But eventually, this led to an interesting question, because we have a commercial platform that companies use. On the weekend, they don't do any work. So on the weekend, we only have like 1/10 of the build traffic on the commercial platform that we have during the week. So it poses an interesting question. If there's no build coming in for 60 seconds, meaning that no build is started for 60 minutes, is that an alert? Does that mean the system doesn't work? So we have this variance of alerts that says, during the week we have this threshold, and during the weekend we have the other threshold that is a lot higher, that it will eventually, that is unfortunately so high that we may miss an hour window of the site not running properly, or some part of the system not running properly. So I started thinking, how can I improve that metric? And the only thing I could start looking at was, so I have to figure out if a build request actually came in from GitHub. I have to figure out if it turned into a valid build, and then I have to figure out how, if it actually started and finished eventually. So I have to figure out if the site is not working. I have to look at the absence of 3 different data series. And I was just like, how do I even do that? That was just that was very curious. And it's not that this is a particularly hard problem, but it's just that's where the focus on technology just, it takes away the focus from helping people to figure out, how they can solve this, how they can solve, the fundamental problem of monitoring their application and figuring out if it is broken or not. And suffice to say, I don't yet have the answer for this question. If anyone wants to help me figure it out, I would love to hear what you have to say, because it keeps blowing my mind even when I start thinking about how to solve that problem, how to reliably detect if our site is down, because it's the whole idea of that. We have other metrics, but this is basically currently our defining metric. And it leads to one problem. We have these thresholds, that may or may not be true. It leads to, oh, it's the weekend, threshold was crossed, it'll clear. So it leads to like this weird conception of, oh, it's the weekend, it's probably okay. It's probably not too bad. It takes, it leaves us with more than an hour. I think it's even 1.5 hours, because from Saturday night to Sunday morning, basically nothing is happening on the commercial platform. Whereas the open source platform is like, they're busy all week. They're basically pushing code all week, all weekend long. We don't even have to worry about that. It's just a commercial platform, which is just very curious. And in the end, we're still in that situation where alerts are still an unfortunately very binary thing. They're just like, okay, this threshold was crossed, threshold wasn't crossed. How you figure out the threshold? It's a weird question. I was just reading a book, Effective Monitoring and Learning on the Flight here. And it talked a lot how you figure out thresholds. And it talked a lot about all the ways that you adjust thresholds over time. And I keep thinking, why do I have to do that manually? Why do I have to figure it out all by myself? It's not that I'm a lazy person. I love staring at graphs all day long to see what is going on a platform. But in the end, shouldn't machines be able to tell me that? Shouldn't machines be able to tell me what the standard deviation of behavior on a platform is? What it normally behaves like on the weekend compared to during the week, and figure out these thresholds automatically? That's one question that has been on my mind a lot, and it leads to rather interesting consequences. I unfortunately don't have the answers to those, but I was listening to a very interesting food fight show the other week on adaptive fault detection, which was like, yes. That is going in the direction I want. It's like I don't have the mental capacity to explain everything that was said in this food fight show, and I recommend it a lot that you go and listen to it. But it sounded like the future of monitoring. It sounded like something where I said, yes, this could help me solve this particular problem. And yeah, I would love to see alerting go away from that problem where you have thousands of alerts being activated every day. Actually, wanted to check if I got one just now. No. But I had one last night, and I ignored it because I was asleep from jet lag, unfortunately. I would love to see monitoring get away from that and closer to being, to following what humans actually need when they to figure out what alerts are, because humans are very, very awesome at being adaptable and figuring out what is happening, but machines should do a much better job helping them to get there. This leads to an interesting conclusion, because if I fully trust my monitoring tool to make the right decisions for me, am I even necessary as an operator? Or am I putting too much trust in the machine? Am I starting to distrust the machine, and I go back to saying, oh, it'll clear? Just rather interesting, because you run into this mix of how do I want to put this? Unfortunately, forgot. But you put a weird sense of trust in the machines, in the computer, in the monitoring system, when you rely on it to always tell you that something is wrong. And that's the interesting juxtaposition, because I would love to see that move more into that direction where it can do that. But on the other hand, you still have, the operator being, can he trust the machine? Does he not trust the machine enough? Or does he have to constantly reevaluate what the machine is doing? There's still that a weird disconnect, even if you go into the direction of adaptive fault monitoring, fault detection, which is probably why going into the realm of looking at alert design and all these cognitive things is a very, very good idea. Just something to think about. The last thing I want to touch real quickly is this is a typical software that a coffee roaster is using every day. Would you enjoy using that software? You have like insane amounts of numbers down here that have dots at the end, just saying whatever. All of them have that, and there's like it's temperature. You have temperature. You have the temperatures in here, the temperature of the bean, and the temperature in the roaster, and the roasting time, and all that. And you have weird buttons, and you have graphs. If I were a roaster, I would throw that away. And I didn't want to touch on any particular software, but as much as we have had technical progression over the last couple of years, making the softwares easier to use for humans and making the software in a way that everyone in the company can start using them, we're still far from doing that. We're still far from being able to throw anyone at a monitoring system or throw people at any graph without giving them enough context. And that context is still something that most monitoring tools don't even allow us to specify and to give people properly. Which is why alert design is just a very, very interesting realm to go into. And something I would love to see more is to help people figure out how they can find what they need to measure in their application. It's not as much going into cognitive things. It starts with simple stuff like telling people how you do monitoring. Telling people how do you end up with the thresholds that you have? How do you end up with the graphs you have? How you ended up collecting building a dashboard that shows the most important metrics of your system, or how you build other dashboards. And there's two things I love to give shout outs to. One is Ops School, which is basically the attempt to build an ops handbook, to build to collect community experience when it comes to operations. And the other one is Hangops. Hangops is really, really awesome. Because it's where people come together and openly talk about what they're doing in their day job, and I love listening to that. I love talking to people, what they how they build their applications, how they monitor their applications and stuff like that. And I love listening to other people talk about it as well. So Hangout's definitely pretty awesome. And what I would love to see from everyone here is tell the world about monitoring, because to make things better, you probably have to start writing it down to realize where you want to be, which is pretty much how this talk came out to be. Thank you.